Hi folks, so today we are ready to hear about motion in a plane, which happens to be the chapter number 4 in your physics class test 11th textbook. You have already studied motion in a straight line in chapter 3 of the same class, and further you have studied some portions in your class 9th and some in your class 8th too. Nevertheless, we will be discussing little more things and then try to understand that what are the concepts which are required to understand the motion of an object in a plane, means 2 dimension, or in space, means in 3 dimensions, where we will be using the whole coordinate system. I am sure that you have already studied the required coordinate geometry, Cartesian coordinate system in your mathematics class as well, and probably your physics class teachers might have also taken these concepts behind discussing the chapters on new Cartesian coordinate system in the chapter on light. Well, let us go ahead in this chapter and see. Let me first revise that what you have already studied in your class 9th or in class 11th in chapter 3. You, while discussing the motion of an object in a straight line, you have taken okay, let me go with some example. Now, you are at point A, say for example, maybe your home. Now, you are supposed to go to your school, which is located at point B, say. Now, often when we do this kind of motion, we go like this according on the roads. Roads are not straight, very practically roads are not straight, these are rather mingled, and or this or sometime like this, or in some rural areas children might be finding they have to reach from point A to point B, covering a larger distance, much larger distance. So, friends, you have seen that from traversing from point 1 to another, you might have to take several paths depending on the conditions. What are these? These are not the motion in straight line, these are the motion along the 2 dimensional planes. So, this is a plane, this is on surface, this is on a plane. So, now look what is happening in this situation. You are traversing in order to move from point A to point B, which are separated by say a least distance s, say a least distance s, but actually you have to traverse a much larger distance than s. So, this is a motion in a straight line. However, these are the practical motions which are straight motion in a plane. Now, you see these are the distance traveled, this is the distance you have moved, or also called path length. I will be using the word, that character P L for path length throughout the lecture, throughout this session. Now, this straight line S, which is the least distance between the 2 points A B along a straight line, is called displacement. Remember, in all these cases you are actually travelling, the displacement is only s. Have you understood? Well, now similarly we can explain the words speed and velocity, that the total path length divided by time taken in during this motion is speed, and the displacement divided by the total time taken is velocity. You understand the acceleration as well, means the rate at which you are changing your velocity. Your velocity might be decreasing, your velocity might be increasing. While going up motion, you always move with a faster speed. So, you increase your speed, you increase your velocity, means your acceleration is positive. But when you are reaching to your destination, you decrease your velocity at a particular rate, say. So, then it means you are decreasing. So, acceleration is negative, and this is also called deceleration in many books. This is also called deceleration, right. So, while discussing in your motion in a straight line, you are taking care of directions by using plus and minus signs. Means if you are removing in plus x direction, say for example, it means your directions or your motions are positive. All the physical quantities, be it displacement, distance, velocity, speed, accelerations, all acceleration the way I told you are taken positive, but when you are coming in negative direction, in opposite direction, then you consider it negative. So, plus and minus take care of your direction, limited direction in this case of motion in a straight line. Moving further to this what you have studied, let recall the word motion. Motion means change of position of an object with time. Remember, at this point there is some confusion in or some different kind of things which you might see in different books. Yes, rest is, many authors consider rest to be a state of motion. Yes, it is, of course, it is a rest of motion. Rest means when there is no change in position with time. Motion, the kind of terminology we are going to take out around in this text is the state of motion is motion when the position of an object is changing with time. Be clear about it. Okay? Be clear about it, friends, that motion, the way we are defining is the change of position with time, right. Now, path length you have already studied, I have already explained what the path length is. So, you understand that path length is always more than or at the most equal to the displacement. Path length is basically the distance traversed during the motion, but it is necessarily either more than the displacement, usually it is more than the displacement in all practical situations. It is very rarely you will find that path length is equal to displacement, very rarely, but in most of the cases path length is more than the displacement, and at the most the limiting case the path length is equal to the displacement. You understand it. Now, uniform motion, what do we mean by uniform motion? Remember, this is an approximation. Remember, in while doing chapter 1, we were discussing the methods, how we study science, how we study physics, how we study quantities, that we always approximate. We had given you some examples for approximation. Remember chapter number 1, that is very important chapter, my dear friends, in your studies in physics, whether you are in 10+2 or going ahead. We wish that you are going ahead in physics for your research studies or in career, but nevertheless uniform motion means when the velocity or the speed is throughout same. Actually it does not happen, but we consider it that as if the velocity or the speed for that matter is throughout same, it does not change, it does not change with time. Average velocity, how do we define average velocity? As in a case of a motion in a straight line, when only x coordinate is changing, when only x coordinate is changing with time. So, the distance displacement between the 2 points taken time delta t. So, delta, the ratio of displacement divided by the time taken in doing it is called the average velocity. Look, if I draw, suppose this is x t graph, position versus time graph, and this is the speed, this is the graph, I am considering a uniform motion. So, this is how it is a straight line. Well, now, if you see this, the slope of it is, this is suppose dx and this is suppose dt. So, the slope of which dx by dt will give you the average velocity or the velocity at between this time interval. The same thing you can show it on different paths. Now, during this interval, during this interval, during this interval, the only thing is that the average velocity during these intervals is different. Now, suppose if you were to take the average velocity between this point from this to this position, from this position to this position, then forget about this path, then your velocity will be, suppose this is x 1 and this is your x 2. So, your velocity will be nothing but x 2 minus x 1 divided by delta t. Understood, my dear friend? This I believe that this point should be clear to you. Okay. Well, now let us talk about the instantaneous, the velocity at a particular instant. The velocity at a particular instant. What is the velocity at a particular instant? Now, if this delta t, suppose this delta t happens to be very small, this delta t, let me draw it again. Yes, see. Now, suppose this is the graph. Now, this is the change x versus t. Now, suppose you are taking it like this between this region, say. Now, this point, this point, this point, it is obvious that the speed is not uniform. Well, no problem, we can study it, we will study it in this chapter throughout, we will do it dealing with this kind of situations, never worry. So, now at this point, suppose if this is t 1 and this is t 2, this is large. Now, if I happen to shrink my t 2 here, so this is very small. Now, if I say delta t tending to 0 is becoming very small tending to 0. it is not exactly equal to 0, but negligibly small. That the difference between T2 minus T1 is negligibly small. So, this is one particular instant. I have hit my palm by this pen at a particular instant and nowhere else. So, the force which has gone onto my palm is instantaneous. You have studied all these things in class 9th while discussing class force in your chapter. So, this is given by when the limit delta t tends to 0. So, this shows you, my dear friends, the instantaneous velocity, etc. So, now let us see further. The instantaneous velocity, the instantaneous velocity is just a limiting case when the delta x by delta t is, then you have studied in the calculus, or if you have done it in physics, your physics teacher has done it very good, but in chapter 3 we have done some calculus, but wait for some time, you will study all these things in a great detail in your mathematics class. Your mathematics teacher will be discussing it on all those things in a much greater detail. So, this converts to, this notation becomes dx by dt, and this is called differentiation. This is called differentiation of position with respect to time. So, velocity is nothing but dx by dt. So, whenever you see this kind of relationship, you must understand that we are talking about instantaneous values, means when the time interval between the two observations is very small, is very small, negligibly small, that you call limit delta t tending to 0. Okay? So, that is point clear. So, the velocity at a particular instant is equal to the slope of the tangent. If you see this graph x versus t, if you are seeing at this point, say, now if delta t is 0, so this is nothing but equal to the slope of the tangent drawn at that point particular instant. So, this is the tangent. You know what the tangent is. You have drawn lot of tangents in your mathematics geometry classes. Well, we will continue doing it in class 9th physics 2 and science 2 in chapter on motion. We have done this business of drawing a tangent and normals, etc. Do not worry. So, after understanding the average velocity, let us now go for the acceleration. The average acceleration is defined by the change in velocity divided by a given time. Now, remember, this is change in velocity, not change in speed. This is very important point. Velocity, not the speed. Remember this throughout. Acceleration is nothing but change in velocity divided by change in time, right. Now, so the average acceleration is given by this equation. You understand all these things, and you understand the limiting. The limiting, if you see it on VT graph, and the time of between two observations tends to 0, negligibly small, that is delta t tends to 0, it means that you are coming from average acceleration to instantaneous acceleration, and this is the acceleration we will talk about throughout the course. The instantaneous acceleration, this is commonly called acceleration at a particular time or a particular instant. So, whenever we talk about we use the word acceleration is this much, it means at a particular time, it means the acceleration is at a particular instant. However, during the whole course of this chapter, and not only in this chapter, throughout in physics up in class 11th and 12th, you will be seeing situations where the acceleration is constant throughout. So, we will be considering that the uniform acceleration cases only, not the variable acceleration. However, it is not the, it is again an approximation, it is again an approximation. So, we are trying to discuss the problem in a unification manner. Remember your class 11th chapter 1, where we were talking about how do we study the physical laws. We discussed the two laws, two phenomena called unification and reductionism. So, this is a case of unification, right. So, now that likewise you get the velocity as a slope of x t graph. Similarly, we get acceleration as a slope of v t graph, velocity time graph. The important point is this is velocity time graph, it is not a speed time graph. Yes, in this slide, if you see in continuation to what you have studied earlier, the area under the velocity time graphs gives you the displacement traversed during this time t1 and t2, and now after that you see these are the three equations of motions which you have studied in your class 9th 2. Remember what is unique in these equations, there is no sacrosancy in these equations. These equations can be rewritten in different forms differently. You can write hundreds or larger number of equations, but we scientists have have been unanimous in understanding these equations motions in these three equations. Otherwise, there is no sacrosancy in these three equations. You can write n number of equations, such equations, and all are equivalent to each other. What we have done here is that we have written, see, you have time in your hand, you have no acceleration in your hand. So, you want to know what is the final velocity and what is the displacement, total displacement. So, your left hand sides, the dependent variables are on those terms only, So, however, these two equations are sufficient to explain the motion, these two equations 1 and 2, these two equations are sufficiently equivalent, and this equation is coming right from these equations, and this is just a simplification manipulation. There is no sacrosancy in it, please keep it in mind. If you are being asked that if somebody says, argues on it, that these are not the only three equations of motions which you are writing, do not worry, say okay, for my convenience I have chosen these three equations. There can be n number of equations, this is just a matter of convenience, nothing else, friends. So, if the position of the object at time t is equal to 0 is 0, then these are the equations. Otherwise, if the position of time of some object at time t is equal to 0 is x naught, then we will just do nothing, but in place of x we will write x minus x naught, like this. So, this equation will become x is equal to x naught plus v naught t plus half a t square, and similarly this equation will become v square is equal to v naught square plus twice a multiplied by x minus x naught, that is true. So, let us now let us see, now let us go for this. How do we study this motion in a plane? Let me come back after this. Motion in 2 dimension, you know, plane, motion in 3 dimensions in all those directions is in motion in space, So, now now in this case you can, now you have to define the things through directions, different directions. So, the scalars are not sufficient, the quantities are not scalars. So, the physical quantities which you will now require to explain the motion are different from what you had earlier in the case of motion in straight line. So, now you have to define some other quantity, the physical quantities in some other terms which involves directions in them. So, these quantities are called vectors. So, we have two kind of physical quantities now, scalars and vectors. I will give more emphasis on this vector. So, you might say, sir, we have studied in class 9 too that there are some quantities, we have understood that there are some quantities which can be explained only through their magnitude. Likewise, the distance travelled, nobody asked that in which direction you have done. Yeah, I have moved, I have roamed 4 kilometers today morning, that is all. In which direction it is? No. So, this is the total path length with, or the total distance which I travelled in the morning. So, this was a scalar quantity because it can be explained just by its magnitude only. I slept for 4 hours. 4 hours is important. So, this 4 hours is important for is all important for giving my sleeping, right. So, this is again a quantity which requires only magnitude, does not require any dimension, which does not require any direction. Now, if I say that I have moved 4 kilometers from my initial position, now this information is incomplete. If I say that I have moved 4 kilometers from my initial position, this information is incomplete. In east direction, west direction, in which direction I have moved, in which direction I have moved. So, this is the basic question comes in. So, now in order to explain this motion that I have travelled 4 kilometers today morning, I have travelled 4 kilometers today morning. Okay. Now, the question is that in which direction you have moved, it means you need to have direction also. So, these quantities which are requiring magnitude plus the directions like velocity, like displacement, these are vector quantities. Remember, we have not told these quantities in your class 9th or earlier, because the reason is that these vector quantities are those quantities which require a particular algebra, a particular equation to satisfy, a particular vector law of addition, which is called vector law of addition, particular algebra. It is different from the simple algebra, mathematical algebra which you have been studying so far in your mathematics classes or in physics classes or wherever you have been using, that is the simple algebra, but this vector algebra is slightly different. You can understand it like this, that I have moved say 4 steps in this direction, right, and then I move 2 steps backwards in this direction. So, 4 steps in one direction, 2 steps back in this another direction. Now, my total displacement is from this point to this point, too small. Now, if I happen to add the total displacements, then I will get a different value. Then I will get different value. So, my total motion is confused. Total motion is confused. So, I will get a different value. Now, no, have you remember what I have to see, that the initial position and the final position, and that you cannot simply get by adding these two quantities, these two physical quantities, like you add in simple algebra. So, this is not simple algebra. So, this is, we need to have a different vector algebra which is called vector algebra. Its multiplication, its multiplication. So, I will be discussing about how do we add the two vector quantities, how do we subtract two vector quantities, how do we multiply two vector quantities, etc., and how do we multiply a vector quantity with a real number. This all I will be doing later, but have you understood? I am sure that you must have understood by now that why do we define a new quantity, new set of physical quantities called vector quantities, and these are different from scalar quantities. So, once you recall, let me sum up it up by saying this, that scalar quantities are those quantities which can be defined through their magnitudes only, and the vector quantities are the quantities which can be defined by through their directions as well as magnitude, but at the same time they follow the special law of addition called vector law of addition. Remember, this vector law of addition is very important, very, very important. I give you an example. Now, if I suppose there are, you see the electric current, there is one wire in which I1 current is flowing like this, there is another wire which joins this point, and this here is the current I2. Now, the two wires join here and gives another current to this current I. So, this I is simply I1 plus I2, right. So, here the direction of current nobody matters, nothing talks about, nothing. So, no matter whether this wire is in this direction or in this direction, or this wire is in this direction or wherever it is, as long as they are added up, so they will keep on adding up. Now, remember, though if you see the direction, current has direction, current has magnitude I1, I2, but still these are not vector quantities. Understand it very clearly, still these are not the vector quantities. So, having said this, you must understand it very clearly, my dear friends, very clearly. This is the catch at this vector point, at this point of study, that scalar are the quantities which require only magnitude to explain. The vector quantities require magnitude as well as direction, but at the same time they follow a particular law of addition called vector law of addition. We are going to talk about this addition just a while ago. Now, means vectors, for examples, you need vector quantities to define displacement, have you understood, velocity, acceleration in a plane. Say either you take a plane or you take a space. These rules you will find can be extended. If you are working in plane, these rules can be very easily extended to space, 3-dimensional space, very easily. So, we are going to discuss here only largely to plane, and this can be defined, rewritten in the form of space very easily. Just you have to add one more component, that is all, nothing different. So, I will be discussing a plane. To a plane, the space is the 3-dimension is very simple then. Now, motion on of object in a plane, they requires projectile. Uniform circular motion is an example of it. Next. Now, let us little further. Scalars are the distance travelled, mass of an object. When you say what is your mass, you do not say in which direction it is. Mass is mass. You never talk about theta. What is the temperature of a body? So many centigrade, 37.67 degree centigrade or 98.4 degree Fahrenheit. That is all, nothing else, no direction. Similarly, time, I had given you an example that if you are sleeping for 4 hours, that is all, 4 hours in east direction, 4 hours in west direction, nobody talks about it. It is nonsense to talk about any direction with the time. So, at the most you can say plus or minus, that is simple. So, and these follow the simple algebra. You have moved 2 kilometers in the first hour, 3 kilometers in the second hour. How much you have moved in the 2 hours? 2 plus 3 by 5 kilometers, the simple distance travel. So, this is following the simple algebra, right. Vectors likewise, as I did this small activity here, moving 4 steps in this direction and then coming back in another direction by 2 steps, and then measuring the initial and final positions. I saw it does not require, it cannot be explained by simple algebra, it requires a different algebra which is called vector algebra. So, they require it is clear, and see, when I say that they follow a particular law of vector addition, this law of vector addition could be triangular law or could be parallelogram law. I will be explaining these things little time after a little time. Now, how do we represent? See, we represent these scalars by, this is an international convention friends, by italic characters. These all are italic characters, okay, and no bold facing, simple italic characters. So, they represent scalar physical quantities, but vector quantities are space, there are 3 methods of writing vector quantities. Number 1, which we are using, writing them straight, no italic. This is your displacement, this is your velocity, this is your acceleration, this is your force, this is your momentum, okay, etc., and so far so on. I am taking the examples of the physical quantities which you have studied so far. Well, then this is now they are I mean bold face. Some books are writing it like this, S and arrow ahead, equally good, or S or simple bar ahead, equally good. There are different notations which are given in different books. So, friends, when I was in school, some of my books used to rotate like write the vector quantities like this. Now, nobody does it like this, but in many books you will find this kind of notation or this kind of notation also. Do not worry, but here now it is easy to word process it. So, we do it in boldface. So, your textbook is largely using in boldface, it is little difficult in typing. So, when we write it, however, we use this notation, because writing in boldface is difficult. So, when you are going to write in your copy in your notebook, please use this notation. So, when I am going to write, suppose here in the text on the board, I will be largely using this, but when I am using something typed beforehand, then I will be using this. Do not worry. So, do not be confused with this symbol and this symbol. Now, remember the modulus of this vector quantity, here is the velocity, is nothing but the magnitude of velocity v. Now, this is the magnitude of velocity. So, this becomes a speed. So, I have written it in italic in the form of scalar, right. This is italic, right. You see, this is italic, right. So, go ahead. Now, we will talk about position vector a little, and then in this so the look this how this vector is represented, how this vector quantity is represented. Now, this is the tail of a vector quantity, this is represented by an arrow, right. Now, the magnitude of the arrow is nothing but tells you the magnitude of this vector quantity. Suppose this is equal to v. So, how long it is? This tells you a comparative study of whether it is a large vector or a small vector, what is the magnitude of this vector. Tail tells you the starting point, the heel, the head tells you the final point of it, and this whether it is the direction tells you the direction of motion, of this thing. Now, the position, coming back to the position, I have taken these diagrams right from your textbook. Now from your textbook I have taken these diagrams just for the sake of clarity, so that you can match it very well. Now, the initial position is considered as the Cartesian coordinate system 0 O origin. So, this its coordinate are 0 0, right. Now, if an object starts moving from this point and reaches to this point, point P. point P, point P. So, this OP whose magnitude is r, say this is x direction, this is y direction, x y Cartesian coordinate system. So, this is called position vector OP. So, friends, in this episode what I have done, I have just reviewed what you have studied before. I have tried to do some vector algebra here. I have tried to explain you what are the scalar quantities, what are the magnetic vector quantities, what type of quantities you will be requiring to explain the motion in a plane or in space. And I have explained that how these vectors are being rotated and denoted, what are the notations behind that, and I have explained the position vectors. Simply, I will be doing little more about this position in the next episode. So, till then, friends, bye.